Hey everyone, welcome back to another video in the Golang series. In the last video, please check it out. But we read a little about the net HTTP package and what it does, how to make a simple GET request, and then we tried writing the first API for ourselves, right? I think this is a good time to start talking a little about Goroutines. If you remember my first video, we discussed a little about why to use Go, and one of the key things that Go introduced was Go routines. It's very similar to threads, but it is managed by Go itself. So when you create threads in any language, they are managed by your operating system. Whereas in Go, if you use Go routines, it is managed by Go context. Uh, and if it helps it helps doing your tasks concurrently. So I mean that is one of the biggest advantages of Go. It is great at handling concurrency. So what exactly it is, I'll let's see. I created a document for you guys. Cool. uh, cool. So it concurrency basically means when you are handling multiple tasks and all of them are in progress at the same time. So, for example, imagine you're cooking dinner, right? You're boiling pasta, you're chopping vegetables, you're heating the sauce. Now, uh, you there's one thing called parallelism, and then there's concurrency. So, parallelism is when you do everything together. Everything is going at the same time. But concurrency is when you start doing something, you and in between you switch to some other task. So, for example, you were chopping vegetables and you saw that the pasta was boiling in the background, and you saw, okay, it's boiled completely. So you stop chopping that, you go on, you maybe take out the pasta, store it somewhere, then you come back. So this is somewhat concurrency. I mean, you were doing something, you switched out to do another task, and then you came back in. Now, concurrency and parallelism, they have a very thin line in between them, and they are often used interchangeably. So and that's fine. It is a hard thing to visualize, but it's fine. Concurrency is when your multiple tasks have been managed at the same time. A single CPU core can rapidly switch between tasks. So A, B, C, you get back to A and B. That's it. But when you have multiple processors, when you have multiple cores, everything is running parallelly. So that is what parallelism means. So again, a very thin line. Now, what is a Go routine? It is a lightweight thread that is managed by the Go runtime itself. Now, actually, let's start creating it. Let's see. I'm going to use the net HTTP package for this. So please watch the last video if you have not watched. Although we'll pretty much cover the basics. So when we make the net HTTP.get request, we want to pass a URL string. So let's say HTTPS maybe youtube.com, and it's going to return me a response and an error. Okay, so let's say response error, and okay, and you know what, actually I'm going to make a function out of this because I want to show you guys something. So let's say get YouTube. Okay, it's gonna take this. Okay, and actually I don't really care about the error right now, so let's just do this, and it's just simply gonna print the response code. I actually doesn't really matter about printf. Let's say printf. It's gonna say the response from YouTube is, say, %v, and let's say response dot status. Okay, and we want one print line also. Print line. Okay, cool. So that's capital. Okay, and I'm gonna define two more functions. Okay, let's call this get Google. We'll just change the URL google.com, and let's say what else? Let's call lead code, and leadcode.com. So this will be Google and this will be lead code. And one other thing, if you've seen my last video, one thing I didn't do over here is we always close when we make a connection. Response.body.close. Same for here. Response.body.close. If you're wondering what defer is or why do we need to close the connections, please watch my other videos. Cool. This is all ready. Now when we execute this, let's say I say get youtube.com, get lead code, and get Google. Cool. If I try and run this, go run main.go, and now we all know what's gonna happen. It's gonna basically just print out the status codes, and first it's gonna hit YouTube. It got 200. It went to lead code. It said 403. Fine, doesn't matter. And then it said get Google, and it's 200. Perfect. Now the thing is, this is a very sequential order, right? So I don't, and it's some time taking process. So I don't wanna, wait for YouTube to complete and then the request to be sent to lead code and then Google. I mean, I can, these requests don't depend on each other, so I can just try to get them going parallelly. Now I said parallelly. I know that's not the right word, because I just mentioned it's a very thin line between concurrency and parallelism. But I hope you get the point, right? These are not things that need to be done sequentially. So that is where I will say I can use Goroutines when I know the sequence really doesn't matter to me. So how to write a Goroutine? It's pretty simple. You just add the word go in front of it, and there you go. That's it. That's all you need to write a Goroutine. Now let's run it. And wait, I did not get anything. Why? Now see, the thing is, while these functions, they were getting executed, a main function ended. I mean, there's nothing else to execute. It does not know that Goroutines are running, so it just exited, and before these could complete, which does make sense, right? So what can we do around here? One thing is I can add some logic. Anything, right? Anything works. I just need something that makes the main function run for a little while longer, while I get the result from here. So I can just do something like, let's say there's a package called time. You might already be familiar with it. It's in a lot of languages, and let's say 1 into time dot second. That should work. I'm assuming everything gets completed in 1 second. Let's see. And there you go, I got the response. But hold on. This is not the best way to do this. Why? See, right now this one itself is an assumption that this is going to get completed within this time frame. But what happens when, let's say, leadcode.com, I say 2, and now if I run, I know lead code is not going to get called because it's just going to exit, because it's going to sleep for 2 seconds, right? So you can't add some logic over here that's going to break every time you make modifications to these functions. So we need a more robust way to do this, right? And fortunately we have a package for that, a package that synchronizes all your Goroutines, and it's named sync. So what do we do is we create something called as a wait group. Let's say var w is sync.WaitGroup. Okay, I think this is it. Yep. Uh, Now, what exactly this does is this takes care of making sure that your that these functions, they are able to the threads are, or the Goroutines, they are completed by the time we exit. So one thing you do is there's a function, if you see add, it basically tells how many Goroutines you're running right now. And one other thing you need to do is you need to pass this as part of your Goroutines. Say wg. If I am doing it here, then obviously I need to pass it wg dot sync dot wait group. Something missing in parameter list. What did I miss? Did I miss something? WG sync.WaitGroup. That seems right. We have the sync imported. Okay, let's come back to this later. But we also, so now once the thread is executed, we do one more thing. We tell this wdg.done, and that's it. That's all you need to do. Now this wait group itself will take care that to make sure to tell the main thread, okay, something is running right now, and make sure that you wait till it exits, and only then you end the thing, only then you end the main thread. Okay, over here, and therefore, okay, and let's try to run it. I don't know what's okay. Still don't know what's there. Let's see. On this pass missing comma. What did I do wrong? 10. Okay. Alright, just give me 1 second. I need to check what happened. Pointer is wrong. Sorry. Cool. My bad. And now if I one last thing, you need to also add in this function wg.wait. And now let's you can see there's already a timer over sleep timer over here, and I've not added anything over here, so I'm just using this wait group itself to make sure I'm able to make sure everything gets executed. Let's run. I got Google, I got YouTube, and I got LeetCode. Now one interesting thing is when you're running processes concurrently, I'm just removing this one now because I'm going to show something else. When you're running processes concurrently, you don't always get the result in the same order. So if I run it once more, you get Google, YouTube, LeetCode. Coincidence? I mean, you can get it same order, you probably won't. Now you see Google, LeetCode, and YouTube, the order changes. So that's the thing with concurrency. The processes may vary in order from time to time, and that's totally fine. You need to design it such a way that you are aware that the ordering would be different, and you're able to handle it. That's it. And so this sync package, it provides you a lot of other things as well. It helps with read and write logs, mutexes. We'll discuss that in a couple of videos, some maybe at the end of the series. We don't really need that right now, but uh, the sync groups are kind of important when you are learning about Goroutines. One thing you can see that I had to uh, add how many processes there are going to be. Then I need to take care of that you know wait to done needs to be set. So this is a lot of overhead. So there's actually a newer syntax. I found this article. I'll share it in the description, which basically just says if you're using Go version 1.25 or above, you don't really need to do all this. You should just declare the sync the wait group, and you write a go routine something like this, and you write a wg wait, and everything else, how many wait groups there are going to be, or they've done, everything else will be managed. So let's try this. I'm going to comment it out. I'll need this. I don't need this, and don't need this. Comment this out. Don't need this. Again, don't need this. Cool. And now to declare the go routine, what I need to do is, let's say I copy this. I'll say wg.go. That's the keyword, and I need to write a function, and inside that function I'll just call what I already have. So this is kind of the syntax that you need to follow. Let's see, get Google, and let's say get date code, and if I run this now, it should still work in the same manner. See, it's the same thing, a lot less boilerplate code, and that's good, right? Makes it easier for us. So that's all I wanted to cover for Go routines, at least for now. There's a lot more we can discuss on this part, but it's not the easiest topic, and if I share everything right now, you will get confused. I'm sure you are already quite confused about this, so I have prepared a readme. Please go through it. It has a lot of things that you can refer to, and please probably watch this video again, because you are going to need it. It's not the easiest thing. In the next couple of videos, or probably at the end of the series, I'll talk about something called as channels. They are used when Go routines need to share resources, or when they need to communicate with each other. And then there's going to be videos related to mutex and how to use that. But till then, please make sure you're a little bit more comfortable with the sync package, what wait group is, and how to write a simple Go routine. That's it. Okay, got it. See you guys in the next video. Bye bye.